All right, let's dive right in. Today, we're doing something a bit different and honestly a lot more interactive. We're tackling an MDCAT 2026 practice test, looking at some seriously tricky multiple choice questions. But we aren't just going to read them and move on. We're going to break them down together. I challenge you to really test your grasp of the foundational rules of our universe today. Whether you're prepping for a massive exam or you just love flexing those mental muscles, this explainer is going to seriously sharpen your understanding of classical and modern physics. Section 1. Mastering Mechanics and Motion. Okay, here's our first question. A projectile is launched at an angle of 45 degrees. Neglecting air resistance, the angle between its velocity and the horizontal at the highest point is A. 0 degrees, B. 45 degrees, C. 90 degrees, or D. 135 degrees. Take a few seconds to lock in your answer.
And the correct answer is A, 0 degrees. Now, what's really fascinating here is what physically happens right at that peak. As the projectile is climbing, gravity is pulling it down, right? It's slowing that vertical climb. So the absolute highest point, its vertical velocity actually drops to exactly 0 for just a split second. The only movement it has left is forward, just purely horizontal. And because it's only moving horizontally, the angle between its velocity and the horizontal plane is exactly 0. It's kind of a beautiful piece of logic once you can picture it in your head.
All right, moving on to our next challenge. We're shifting scales here, from tossing a little projectile to launching something entirely out of a planet's gravitational grip. Here is the question. The escape velocity from Earth depends primarily on A. Mass of the object, B. Radius and mass of Earth, C. Air resistance, or D. Shape of the object. Think about the forces really at play when you're trying to break free from a planet. Go ahead and take a moment. Okay, the correct answer is B. It depends primarily on the radius and mass of Earth. The key takeaway here is that it's all about the planet itself, not the payload trying to escape it. Escape velocity is just the speed you need to break free from that gravitational field. And the strength of that field, well, that's completely dictated by the Earth's mass and how far you are from its center, its radius. It absolutely does not depend on the mass or the shape of the escaping object. So whether you're launching a tiny little satellite or a massive, sprawling space station, the speed threshold to escape Earth is exactly the same. Section 2. The flow of electricity. Let's pivot and test your circuit knowledge. Here's the question. Two resistors of 6 ohms and 3 ohms are connected in parallel. The equivalent resistance is A. 9 ohms, B. 2 ohms, C. 4 ohms, or D. 1.5 ohms. Do a quick calculation in your head. Let's see if you can nail this one. And we're back. The correct answer is B. 2 ohms. You know, this brilliantly shows why understanding the formulas is just so crucial. Let's quickly walk through the math together. Step 1. Identify the parallel formula. That means 1 over the total resistance equals 1 over R1 plus 1 over R2. Step 2. We plug in our values, giving us 1/6 plus 1/3. If you find a common denominator, that 1/3 becomes 2/6. Add those up, you get 3/6, which simplifies nicely to 1/2. And finally, step 3, just flip that final fraction to solve for the equivalent resistance, and boom, you calculate exactly 2 ohms. It's just a perfectly satisfying mathematical puzzle, right? Let's keep this electrical momentum going. Question: which instrument converts electrical energy into mechanical energy? A. Generator, B. Transformer, C. Electric motor, or D. Rectifier. Think about the devices you use literally every single day. Which one takes electricity and turns it into physical movement? Take a beat to think it over. Got your answer? The correct answer is C, electric motor. Now, this is a classic area where people get tripped up, so let's compare them directly. An electric motor takes electrical energy, say power from a battery or an outlet, and spins, creating mechanical energy. Compare that directly to a generator, which does the exact opposite. Picture a wind turbine. It takes the mechanical energy of those big spinning blades and converts it into electrical energy. Remembering that inverse relationship really helps solidify the distinction in your mind. Just remember, motor for movement, generator for juice. Section 3, electromagnetism and light energy. Okay, here's the next one. Which law states that the induced EMF is proportional to the rate of change of magnetic flux? Is it A, Coulomb's law, B, Faraday's law, C, Ampere's law, or D, Gauss's law? This one is purely a test of your memory regarding the heavy hitters of physics history. Which scientist's name is attached to this very specific phenomenon? Lock it in. If you guessed B, you are absolutely correct. It's Faraday's law. By definition, Faraday's law states that the induced EMF, or electromotive force, is proportional to the rate of change of magnetic flux. To put it in simpler terms, if you change a magnetic field around a coil of wire really quickly, you induce a larger voltage. Actually, this is the exact principle that makes those generators we just talked about actually work. It's all connected.
And we've arrived at our final question, which ties this entire journey right into the behavior of light and photons. If the frequency of light increases, its photon energy, A, decreases, B, remains constant, C, increases, or D becomes zero. Think about the color spectrum for a second. From low-frequency red light all the way up to high-frequency blue light, or even beyond to ultraviolet. Take a few seconds to decide.
The correct answer is C, it increases. What's absolutely fascinating here is the fundamental rule of the universe that this represents. There is a direct, unbreakable relationship between the frequency of an electromagnetic wave and its energy. As frequency goes up, the energy inherently must go up. It's exactly why high-frequency ultraviolet light can give you a nasty sunburn, while low-frequency radio waves are passing right through you harmlessly every single day. Section 4. Scoring your physics knowledge.
So all of our challenges today were pulled directly from the text, Foundations of Classical and Modern Physics. And what I really hope this explainer showed you is that these aren't just, random disconnected multiple choice questions. They actually represent the beautifully interconnected fundamental machinery of our entire universe. From the simple arc of a thrown ball, to the invisible pull of a massive planet, to the flow of electrons in a circuit, and the raw energy of light itself, these laws govern absolutely everything around us. So I want to leave you with this provocative question. How well did you understand the foundational rules of the universe today? Whether you totally aced it or maybe found a few blind spots, I challenge you to view your score not as a final grade, but as a starting point. Let this inspire you to dive even deeper into these physics concepts. Keep questioning, keep visualizing, and I will see you in the next explainer.